Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the SN2AR. SN2AR means what? Aromatic nucleophilic substitution bimolecular reaction, and with the help of some suitable example we have seen that how it is taking place. So that type of the thing we already discussed yesterday, and today what we are going to discuss, let us look at here SN1AR, aromatic nucleophilic unimolecular reaction, aromatic nucleophilic substitution unimolecular. I think here the substitution unimolecular reaction. S stand for the substitution. Aromatic nucleophilic substitution unimolecular reaction. In this way you can remember the short form of this SN1AR. AR means aromatic, N stand for the nucleophilic, S for the substitution and 1 for the unimolecular. So this is a general term used here for SN1 unimolecular reaction. So what type of the aromatic compound shows this type of the nucleophilic substitution reaction? And as we know that the aromatic compound, are we already seen that, or we have already studied that the aromatic compound easily undergoes electrophilic substitution reaction, because whatever the intermediate form, that is valent intermediate, we can call it as a rhenium ion, that rhenium ion is well stabilized due to the resonance, and due to this reason the aromatic compound generally undergoes electrophilic substitution reaction. But in some cases, in a rare cases, some of the aromatic compound is found to be undergoes nucleophilic substitution reaction. One example we have seen in case of the first one, SN2AR. AR means aromatic, N stand for the nucleophilic, S for the substitution and 2 for the bimolecular, and that example we have seen in the previous. So today we are going to learn and how this SN2 are analogous with the SN2 reaction, where the saturated nucleophilic substitution reaction, the kinetic study showed that the bimolecular reaction means the rate of reaction depend upon the concentration of the substrate as well as attack of that nucleophile. Two molecules are involved in the reaction, in a chemical reaction, and therefore it is termed as a bimolecular. But in this case we are using as a unimolecular. Remember here how to remember this. AR means aromatic, N stands for the nucleophilic, and S for the substitution, and unimolecular means single molecule. So here do you remember the diazonium anion, diazonium cation or diazonium salt? Let me tell you as a diazonium salt, and how the diazonium salt is formed. In your previous classes you already studied at T.Y.B.Sc. there is a functional group interconversion. Under that heading you already learned this type of the thing, diazonium salt, how the diazonium salt is formed. Once it is formed, it is a versatile organic compound. Variety of the organic compound we can prepare or we can synthesize by carrying out the different type of the reagent, by adding different reagent over it, and you will get as a different product over there. And so here diazonium salt aniline. Generally diazonium salt are formed when there is a aromatic primary amines are present. Only and then there is a formation of the diazonium salt. Remember, aniline is one of the organic bases, or what we can call it as a primary amine, which is aromatic in nature. And when the diazonium salt, you know that what is that, NaNO2 in presence of HCl, the reaction condition required very essential or very proper reaction condition. This reaction takes place under low temperature. The temperature should be kept 0 to 5 degrees centigrade. Then and then diazonium salt is formed, and once it is formed, you can treat this diazonium salt with a different reagent. You will get the different organic compound, that is a specialty. But in this case, what is going to happen? Diazonium salt, as we know that this is I am directly writing as a diazonium salt here. N triple bond, N positive charge over there and negative, and here may be as a X when the aniline treated with the HCl. Generally here you can write as a chloride over there, Cl, and this is called as a diazonium salt. This is a diazonium salt, and generally this diazonium, the driving force behind it, what is happening, this moves like this, so that we are going to get over here, this is the carbon-carbon double bond, positive charge over there, and then there is a what we can call it as a positive charge over there, and nitrogen triple bond over there, and this nitrogen molecule is a very stable one, and but the positive charge present on that aromatic ring, it is highly unstable, because that positive charge cannot be delocalized into that pi orbital, and therefore immediately when we are adding any nucleophile over there, it gives the nucleophilic substitution reaction. Here the Y is attached over there, and there will be the elimination of nitrogen, and which is gaseous in form. It goes in the atmosphere. As we know that the percentage of nitrogen atom in a year nearly is 78% is there, and therefore this type of the reaction is called as a SN1 SN1 means that aromatic nucleophilic substitution reaction, how that nucleophile attacking on the benzene ring, and we are getting as a monosubstituted benzene. Here also this showed the similarity with the ipso type of the substitution. Ipso type of the substitution means what? The group or the substituent present on the carbon atom, it get replace same carbon atom. The nucleophile attack means the replacement of that nitronium ion or the nitrogen and from nucleophile, and you are getting as a monosubstituted benzene over here, and that's why the careful kinetic study of this chemical reaction suggests that rate is directly proportional to the concentration of the Ar N2 plus. In short, we are writing Ar means aromatic compound, this meiotic, and N2 is nothing but as a diazonium salt of that form, and therefore rate is equal to K1 into concentration of Ar into N plus. So this, and here K1 indicate as a first order rate reaction or the rate constant. K1 is a first order rate constant. So this is the kinetic study showed that that is 1. Why it is 1 is written over there? That is a aromatic nucleophilic substitution unimolecular reaction, and this shows as a similarity with it. SN1 means it is analogous with SN1. SN1 means what? Nucleophilic substitution unimolecular reaction. But here there is a aliphatic compound, here is a aromatic compound, and therefore SN1 AR means what? This is a aromatic compound. AR indicate as a aromatic compound. Rest of the words remains the same, and therefore it is analogous with this, means the rate law shows that it is a only one molecule is involved in the rate, because here in the first step it is a slow step, and as we know that slow step is a rate determining step, we can easily measure the rate of that reaction, and then when the nucleophile is attacked, that step is a very fast step. We cannot determine how much time is taken to complete the reaction, and therefore this type of the reaction is called as a SN1 AR, means aromatic nucleophilic substitution reaction. In this way we have seen SN2 AR, SN1 AR. Now let us move on to the next one. What is that? Elimination addition reaction, and it is a very important as per exam point of view is concerned. Let us see what is that reaction and how it can appear in the aromatic compound that we are going to learn over here. What is that? That is a elimination addition reaction. Now here the elimination addition reaction, elimination addition reaction via, it is via benzene intermediate. It is very important, via benzene intermediate, benzene intermediate, benzene intermediate. And as we know that intermediate in every organic, in some of the organic, when the reaction takes place, there is a transition period that is called as a intermediate. Some short-lived intermediate are formed. Some of them may be isolated, some of them may not be isolated, but their existence is proved by using the different chemical reaction on it, and we can show is existence of that short-lived intermediate, and therefore intermediate is one of the important concept for as far as the organic chemistry is concerned, and therefore this elimination addition reaction via benzene intermediate, as we know that benzene, right? And here we know that benzene we are writing as a spelling Z-E-N-Y, benzene. Last suffix, if you look at, if you observe carefully, what do you see over here? E-N-E indicate as a carbon-carbon double bond, right? Carbon-carbon double bond is just like as a alkene. We are putting the suffix E-N-E, means indicating or suggesting carbon-carbon double bond is here. Now if you look at here, Y-N-E means there indicate as a, there is a carbon-carbon triple bonds are there. This E-N-E, now E-N-E indicate as a carbon-carbon double bond. Similarly, Y-N-E indicate as a there should be carbon-carbon triple bond in that organic compound, and therefore Y-N-E means carbon-carbon triple bond, and therefore benzene, as we know that benzene E-N-E means carbon-carbon double bond. There is an alternative carbon-carbon double bond and single bonds are present in the benzene. We know that how it is stable one. Now the last suffix is a Y-N-E indicate that there is a carbon-carbon triple bond is present, and that's why this reaction as far as the exam point of view is very important. Elimination addition reaction means via benzene intermediate. The name itself indicate that elimination means remove some of the atom from the substrate, and then addition means what? Once the elimination takes place, addition means there is a addition of some of the atom or group from the reagent and we are getting as a product. So that type of the reaction is called elimination addition reaction. Look at first, what is the elimination? Means there is a removal of some of the atom from the substrate or from the starting material or from the reactant, and that's why it is known as elimination. And addition means what? After the elimination there is a addition, means addition of the atom or group of the atom in the starting material or the substrate, and we are getting the reaction, and that type of the reaction are known as addition, known as elimination addition reaction, and in bracket written as a via benzene intermediate, via benzene intermediate, and then we are getting as a that type of the product. Let us look at here some of the example. Generally the benzene, as we know that it is a nucleophilic in nature, and whenever we are adding as a nucleophile, there is a very difficult to reaction to take place. There is a no possibility of reaction at all, but when the benzene, monosubstituted benzene specifically, or what we can call it as a, when the benzene ring contains or benzene ring has a electron withdrawing group, and when the such a electron withdrawing groups are present in the benzene, what they do, they remove the electron from the benzene, and at that time benzene feels the electron deficient in nature, and then there is a possibility, there is a what we can call it as it favor the attack of nucleophile on that benzene ring, resulting into the formation of the products are there. Now let us look at in this case specifically chlorobenzene when treated with sodium amide at minus 33 degrees centigrade in liquid ammonia, there is a formation of that aniline takes place. So that is a possibility. So aniline in this way we can prepare in a large amount in a laboratory as well as in the industry. So let us look at how the elimination addition reaction takes place over there. Generally here let us see the starting material. Simple benzene cannot show this kind of the elimination addition reaction. Only those organic compound shows this kind of the reaction, those containing as a strong electron withdrawing group, or the generally remember as a aryl halide. Aryl halide means what? Benzene compound containing as a halogen atom. They can proceed via benzene intermediate. Remember those aryl halide, they can show the such type of the reaction, and therefore now I am taking here the chlorobenzene. As we know that chlorine atom is a electron withdrawing group, it withdraws the electron from the benzene, and therefore making that benzene ring or that benzene nucleus electron deficient in nature, and therefore the nucleophile now can attack on it and resulting into the formation of the product. Generally this is a as we know that this is a chlorobenzene, and when the chlorobenzene, the nature of that chlorine or the any halogen atom, they has a tendency to withdraw the electron from the benzene nucleus, and that benzene nucleus now become as a sufficiently electron deficient in nature, and now the nucleophile can attack on it, and we are going to get the formation of the product. And now when it is treated with a sodium amide, NH2 is known as a sodium amide. This is known as a sodium amide, and this reaction generally carried out at low temperature. The low temperature in liquid ammonia, NH3, and what is that? Minus 33 degrees centigrade. That is the generally temperature kept is low in this case, and there is a formation of what type of the formation of the product we are going to get, and you are going to get the formation of the product over here is this one. Here NH2 and plus what we can call it as a Cl minus is a leaving group in this case, in this particular reaction. So these type of the things are happening here. Now how the mechanism we can show over here. The mechanism, now as we know that in this case here is a chlorine atom. Now this chlorine at ortho position there is a hydrogen atom. I am showing on one side there are two ortho hydrogen atom, two positions are identical, this position, and now in this case NH2 minus, this amide can abstract the ortho proton from here like this, and it leaving its bonding pair, and that the departure of the leaving group, and here we are going to get such type of the intermediate over here. Now look at here carefully, there is a carbon-carbon triple bonds are there, and this type of the intermediate is known as a benzene intermediate. Look at this one is a benzene intermediate, and now the attack of what is that? NH2 minus. Now the attack, there are two possibilities. It can attack here also as well as here, but this is a symmetrical molecule, and therefore either this NH2 is going to attack at this point or at this point. The resulting compound is the same, only the monosubstituted what we can call it as a monosubstituted benzene, and which is a aniline. So we will get here NH2 there. Write this one. Now but in some other cases, now what is going to happen, let us see over here. So here just I am taking the one more example over here, and from that you can easily understood what does it mean. So let us see here the starting material. I am going to take here this one, the name of that starting compound you might be knowing. Here I am taking CH3, and here is a chlorine. What is the IUPAC name of this compound? The name of this compound is a para-chloro methyl benzene. This is a methyl benzene, para-chloro-methyl benzene we can call it, or we can call it as a para-chlorotoluene, doesn't matter. So para-chloro-methyl benzene, which is the IUPAC name of this compound, and when it is treated with this one plus NH2 in presence of liquor ammonia NH3 at minus 33 degrees centigrade gives two products. These two products, one we are getting here is a CH3, another one NH2, and one more product we are getting here, this one, this is a CH3, and now another one is a CH2, NH2, right? Now, if you observe these two reactions, what do you see over here? The name of the this is the expected product, right? This is the expected product I am writing here. This is a expected product, expected, and this is the unexpected, unexpected product, unexpected. Remember here, what do you think? Which one is the major? Because more than two products are formed, there is always competition between the two products. One is formed in a higher percentage and one is formed in a lower percentage. Which one is a form in a higher percentage? Let me tell you here the percentage of formation of this expected product and the unexpected product. The unexpected product is a form as a measure. This one is formed as a measure. The percentage given is a 62%, whereas unexpected product is a minor in case, and that is a 38% only. 38%. Why this is happen? We are getting as a, the name of this compound is a para-amino-methyl-benzene. This is known as a para-amino-methyl-benzene. Methyl-benzene, and the name of this compound is known as a this one is a look at here, this position is a meta position, and therefore it is known as a meta, or you in short you can write as a meta-amino-methyl-benzene, but which is higher in percentage. How do you explain this? Now when you know the mechanism, you can able to explain or you can able to justify this one. Now let us see the mechanism why we are getting unexpected product is a higher than the expected product. That you are going to learn from the when you are knowing the mechanism, then and then you can clear why this one. So here is written as a benzyne intermediate. Now let us look at as a mechanism over here. Now how to show that mechanism? See over here how the mechanisms are taking place and why we are getting the unexpected, because generally as we know that aromatic compound, they undergoes as a electrophilic substitution reaction giving ortho-para and the meta director, as we know that depending upon the nature of the substituent present on the benzene ring. But here is a we are getting one is a para product, another one is a meta product, because here we are talking about the nucleophilic substitution reaction. Nucleophilic substitution reaction are totally different than the aromatic electrophilic substitution reaction. Now let us look at as a mechanism over here, and here we are writing this one, see clearly here CH3 chlorine atom over there. Now here we are using NH2 minus. What the NH2 minus this nucleophile do in this case? Here look at, this is a chlorine halogen atom. Near the halogen atom, whatever hydrogen atoms are there, they get abstracted by the nucleophile. These are the hydrogen atom. This nucleophile can attack this hydrogen atom over here, and that leaving the bonding pair, and then HCl get removed from it, and so that we are going to get here the product, what we can call it as this intermediate. This is known as a benzyne intermediate. Benzyne intermediate, this one intermediate. This is a benzyne intermediate. And now look at this position. There is a methyl group. With respect to this group, this position is known as, this is a unsymmetrical molecule. This is the unsymmetrical molecule here, unsymmetrical, and therefore look at this benzyne, carbon-carbon triple bond, it is known as a benzyne intermediate. Now this position is a different and this position is a different. When the NH2 attack at this position, then and then we are getting as this product. Now here I am showing this NH2 minus is attacking at this position, and when it is attacking from this side, we are getting the formation of the product over here. This one is a CH3, another one is a NH2, and next one will be this one, that is CS3, and here is a NH2. Here we are getting as a 62%, here only as a 38%, means this is a major product and second one is a minor product. This is the product we are getting over here. So there are the two type of the mechanism are involved here. Two-step elimination, addition, reaction. Why elimination? First one is the removed. In the first step, elimination of the hydrogen from this side, and we are getting as a formation of the. So this is a step number first occur over there, and then attack of nucleophile. This is a step number second. Means this reaction involves two-step mechanisms are there, and therefore it involves two-step mechanism. First step is a attack of that nucleophile, abstract the proton from here and form the intermediate. This is the first step occur here there, and second step then attack of nucleophile on a benzene intermediate and abstraction of the proton from the solvent, generally liquid ammonia, and resulting the formation of that para-amino methyl benzene and the meta-amino methyl benzene. So in this way we are getting this type of the products are there. Suppose how do you confirm the presence of this benzene intermediate support for the formation of the arine intermediate? Suppose you have a compound here like this. Let me draw some of the compound over here and I am writing here are the three compounds, and those compounds are here. Let me write CS3 here also as a CS3, and I am putting here is a Br, and here also I am writing here CS3, here also as a CS3, here also as a CS3, another CS3, and here I am again putting as a Br, or maybe as a Br, and now here I am putting another one. Here I am putting as a what we can call it as CS3, here also as a CS3, and here I am putting as a iodine. And now this type of the reaction are possible only there is a aryl halides are there. If you look at here this structure, first structure carefully, what do you see over here? At ortho position, this is a halide, right? Bromine atom is nothing but as a halide. Its ortho position there is a methyl group and there is a no hydrogen atom, and therefore such a type of the reaction do not show elimination addition reaction, or they do not proceed via benzene intermediate. For formation of the benzene, it requires the ortho hydrogen. If there is no hydrogen, if you look at these three structure, if you observe these three structure carefully, all the three, this iodine, a methyl group, this methyl group, there is no ortho hydrogen atoms are present, and therefore all these structure do not show this type of the reaction. Nucleophilic substitution reaction does not occur in such cases. So that is the support of that. And now what type of the intermediate that benzene can form? So intermediate or the another support for formation of that benzene. So when the benzene, as we know that benzene is nothing but here a double bond. Now we can put one hydrogen atom over here and another one we can show over here. So this is a, now let me see properly over here. Now here, so double bond here, another double bond, and now here we can put as a one electron over here, one electron over here. This is a benzene intermediate, it can accommodate 2 electrons, or we can show like this we can show double bond over here. Both the electron we can put here, and another here is a negative charge, here maybe as a positive charge, or this we can show in another way like this. That is this double bond over here you can put as a vacant, means positive charge over there, and here you can put both the electron, that will be the negative charge. So that are the interconvertible. I think with this we have learned what do you mean by the elimination, addition, reaction, and this is known as a via benzene intermediate. This is one of the best or the suitable example from this reaction. In the next lecture we will see the existence of that, how it is isolated. That are the thing we will see in the next lecture. Let us stop today here. Have a nice day. Thank you.